Welcome to the CADWOLF tutorial on equations. Equations are the backbone of a CADWOLF document. This tutorial explains how to edit equations to get the values that you're looking for, and explains what built-in functions are available to users. To add an equation to the document, the user simply selects the desired item, and then clicks the equation line in the Insert an Item bar. Double-clicking on the default text, the user can enter any equation they desire. Entering a is equal to 1 and pressing enter results in a variable named a whose value is set to 1. The rules for what the name of an equation can be are fairly simple. Basically, using the format that we saw before, with something like x is equal to a plus 2, the name of this variable would be x. What that means is that whatever's to the left of the equal sign is the name of the variable. The name of a variable must contain at least one letter, it must not match the name of any known constants or units, and we can't use the name temp equation. The names are not case sensitive. Let's look at another example. Looking at a variable named distance1, which we set to 10 meters, we create a second variable named distance2 and set that equal to distance1 plus 3 feet. Notice that the resulting variable named distance2 was able to take into account the value of distance1 plus its units plus the numerical value of 3 and the units of feet. We're going to talk more about units in a minute, but right now let's talk about matrices. CADWOLF has a great deal of functionality dealing with matrices and vectors. As we'll show in a second, there are a number of ways to create a matrix or a vector. And once those items are created, CADWOLF will recognize them as a matrix or a vector and deal with them accordingly. Looking at an example, you see we've created a matrix named matrix1. We've done this by simply adding an opening bracket, some numbers separated by commas, and then separated by a semicolon for rows. Another way to create a vector is through the linear spacing function shown here. This function is invoked by simply having an opening square bracket, a starting number, a middle spacing number, and then an ending number followed by a closing bracket. All of these are separated by semicolons. The result of this is a vector that goes from the starting number to the ending number in increments of the middle number. By default, CADWOLF will display any equation that results in a matrix as its size and not its value. We'll take a look at how to change this in just a second, but for right now, let's take a look at some of the built-in functions that CADWOLF offers. A built-in function is simply some sort of functionality that's downloaded as part of the CADWOLF platform. As you saw in previous equations, addition, subtraction, division, and multiplication are obviously included. CADWOLF was also able to recognize complex numbers, and it has a number of other built-in functions ranging from trig to a differential equation solver and FFT functions. These items are invoked simply by using their name following by an opening parentheses. To start with, let's look at a really quick example where we've multiplied, divided, and added a number. Notice that CADWOLF not only did the math properly, but it also displays it properly. Moving on, you can see that complex numbers are created by simply having a number plus or minus a number with an I next to it. One commonly used built-in function is the power function. This function is invoked by simply having its name in an opening parentheses. This function takes in two inputs, the first being the exponent and the second being the base. Those inputs can be numbers, as you see here, or they can be variables, or they themselves can be equations. Hitting enter to prompt the equation to solve itself, you can see that once again, this function solves the problem and displays it properly. It also accounts for units. We have a large and growing number of built-in functions, which you can see from a document in our documentation folder. From this document, there are links to every function, which show how to use them, what their inputs are, and what you can expect to see if you do something wrong. The user can also create a function within a document and then use it later in the document. You see that carried out here. We have a variable named a variable named b, and an equation named c, which is set to a plus b. The user then calls the function c, but sets a equal to 5, and you can see that the result is in 7. You've already seen quite a few functions with units in them, but let's talk about how to use them properly. To add a unit to any number, simply enter 1 from the available list after that number. The full list of units available to the user is available in the unit conversion view. Once entered, CADWOLF tracks these units throughout the entire document and makes sure that they're used properly. Looking at an example, you can see that we have a number 10 kilograms times 5 meters divided by 8 seconds plus 5 newtons. As CADWOLF solves this equation, it moves left to right and realizes that you're creating a newton and that you added it to another newton. To accomplish this, for each equation and for each item in an equation, CADWOLF creates what it calls a quantity. A quantity is something like a length, a force, a mass, or some sort of scientific value. Users are allowed to add or subtract only items of identical quantities. This means that you could add or subtract 2 lengths, which means an inch to a meter, but you couldn't add or subtract a length and a mass, or a mass and a force. In other words, CADWOLF doesn't let you do something that's not mathematically proper. To help users diagnose problems with an equation, CADWOLF provides what it calls an equations help bar. This bar is on the right side of the screen and is brought up by clicking on the sprocket in the upper right hand corner of an equation block. The equations help bar has 6 different windows which the user can access. As you see here, we click on the sprocket and the bar appears. The first window provides the basic information for the equation: its name, its value, its units, and a few other things. A drop box on the right hand side of this window lets the user set this equation so that it cannot be edited in use mode. The next box lets the user change the units that the solution appears in. Solutions initially appear in metric units. This can be changed within the drop bar. For a matrix or a vector, the left-hand drop box lets the user switch between showing the size of the solution and its actual values. For each equation, CADWOLF creates what it calls models. The next window lets the user see those models. One is created containing only the numbers that CADWOLF used in the equations, the dimensions, the units, and the quantities. This is helpful for a number of reasons. First, it lets the user understand how CADWOLF saw the equation. Second, the user might realize that the values being pulled and used aren't what they intended them to be. Third, if there are any errors, this will help the user understand how they originated. The next window shows the user what equations depend on this one, and which equation this equation depends on. There is a window to show errors, and a window so the user can enter references as well. To better illustrate this, let's go back to a previous equation, where we added distance 1 plus a number. You can see in the window showing the dependence that it depends on the previous value of distance 1. Before we finish, let's talk a little bit about equation hierarchy. Remember that in a document, equations are solved top to bottom. To use one equation in another, that equation must appear before it in a document. And if by chance there are multiple equations with the same name, then the algorithm will find the most recent incarnation of that equation. Whenever you create an equation by importing an input from another file or from a dataset, the location of that equation is given as 0. This means that you can start using inputs from other files or from datasets in the very first equation on the document. Let's say that for an example, you had equations A and B, and then C was the result of their sums. This would work properly because equation C could find equations A and B. However, if you tried to put C in the second spot, B wouldn't exist to it, so it would produce an error. However, if there was an input named B, then the equation C would be able to see that. This input could come from either a dataset or from another file. If 2 equations named B existed before our C equation, then the equation would use the most recent variable named B. Well, that's it for equations. Probably the best way to understand them better is to take a look at our examples and the validation folder. To keep up with everything that's going on, follow us on Facebook and Twitter.